Go.
Hello, Mr. Fedor. Welcome back. We are talking about binomial distributions and how to find a probability using a binomial distribution table. So the worksheet that we have here is one of the worksheets that you were given in your packet. And again, the key information is the sample size we know is 12. The probability of success is 20%. So again, we're going to start off with those two pieces on our table, and we want to know, for the first question, what's the probability that we're going to be successful exactly 7 times? So if we know these 3 pieces of information, we're going to go to our table to find that probability. So looking at our table, okay, if we scroll up a little bit to get to n is 12, okay, what we see here is, okay, our sample size is 12. At the top of the chart gives us our probabilities. So if we go up to the top of the chart for a second, we have 5%, 10%, 20%, 30%, so on and so forth. Okay, again, what we want to know is 20%. So we're going to be using this second column. So again, if we go up a little bit, okay, a probability of 20% with a sample size of 12, okay, we're looking for n being 7, okay? And if we go across there with n being 7, okay, it's 0.003. So for our first answer on our worksheet, the probability would be 0.003. So anytime it's in exactly, it's just a matter of looking up those 3 values in the table to find a probability. So again, the probability of this happening is very small, less than a 1% chance of that happening. In example number 2, we're saying the probability of at least 2. Okay? So again, this value we said was 0.003. The probability for number 2 was at least 6. So again, the word at least means greater than or equal to. So we're going to look up values that are larger than 6. So going back to our table, if we scroll down, okay, values of 6, 7, and 8, okay, when we look at that table, can we blow this up a little bit? Okay, so n is 12, p is 20%. When we look at those values for 6, 7, and 8, okay, what we notice here is that we have a value for 6, we have a value for 7, but we don't have any values past for 9, 10, 11, and 12. Okay, so all we're going to look up here is 0.016, 0.003, and 0.001. And when we have multiple probabilities, we're going to add them. So the probability of being at least 6 would be 2%. And again, if there's nothing after the table, that means that the probability is insignificant. It's basically 0, so there's nothing to find there. Right? For number 3, the probability that we have less than 2 successes. So less than 2 is going to be 0 and 1. Okay, those are the values that are less than 2. So if we go back to our table, okay, for values of 0 and 1, okay, we have 0.069, okay, and 0.206. And if we add 0.069 and 0.206, we're going to end up with 0.275 as our probability. So in our first 3 examples, we've had an exactly, where we're looking up 1 probability. We've had an at least, where we're looking up multiple probabilities, that value and greater. And we've had a less than, where obviously we're adding those values. Now, in number 4, exactly 4 failures, okay? Whenever we're talking about a probability, we're talking about it in terms of success. So if they say 4 failures, what we want to say is, well, how many successes is that in this sample? Well, if there are 12 people and there are 4 failures, that means success is going to be 8. So we want to look up x equals 8 and not x equals 4. And if you do look up x equals 8 on the table, okay, that's going to give you a value of 0.001, okay, which was our last probability there. Okay. The final question for number 5, okay, the probability that you're within an interval greater than 2 and less than 5. So what values are greater than 2 and less than 5? X equals 3 and x equals 4. Again, those values, okay, on the table, which I think we have an idea of how to use that now, are 0.236 and 0.133. So if I add those two, 0.369 would be our answer there. So that's how we're going to use a table to find binomial probabilities. Now, if we scroll up a little bit to look at question 2, okay, going back to what we talked about in the last video, okay, we're trying to find the mean and the standard deviation of a sample. Okay, so if I have 9,000 Connecticut high school seniors, again, that's my sample size, and we're saying that 52% of them, okay, which is my probability, are taking a statistics course. So 52% of 9,000 means our center is going to be 4,680. Okay. To find our standard deviation, we're going to take n times p times q. And again, if 52% are taking statistics, then 48% are not taking it. Okay. And that standard deviation comes out to about 47 people. Okay. So again, center and spread for our distribution. Okay. So hopefully, after watching this, you can find probabilities using a table, and again, also be able to find the center and the spread, the mean and the standard deviation of a binomial distribution. Okay, until we see you again, have a good day. Thank you.